Good afternoon for our last video for the night because it's getting late. Lucy's in here. Lucy's my little black dog. But anyway, young chemistry scholars, my coach Scott's here. We're going to do one more gas law problem. And this is another combined gas law. Try this with my new little Wacom. Let's see how this thing goes. So if you see right here, I've got a couple of things going on here, right? And let's see if I can move this on up. There we go. All right. So, gotta hit draw. Okay. So I got my draw here, and that's good. So what I've got here is I've got a volume, 400 milliliters, right? And that's subject to this temperature change from 22C. So I've got V, I've got T, and a pressure change. So I've got all three. This tells me I've got a combined gas law problem. So how do we do any of these problems? First of all, we're going to set up our variables, right? We're going to set up our variables. So let's go P1, P, T, V. And on this side, P, T, V. Now this is our initial, so we're going to call that 1, 1, and 1. This is 2, 2, and 2. Now let's identify what we've got. Our first volume was 400 milliliters. All right, let's see if we can do this. Yeah, looks good. All right, that's equal. Let's go ahead and put an equal sign here too. And an equal sign here on the pressure. Let's leave the temperature alone for a second. Now I see my 760 millimeters of mercury, so that's our pressure unit. I'm going to write that in like so. Oh, yeah. There we go. All right. And the temperature, we'll get that in a minute. My second pressure, all right, is going to be what? 360 millimeters. I do that. Let's put a unit there just to be, so we won't be sloppy. We'll leave the temperature alone. I don't know what my final volume is, so this is going to be my unknown. So we'll call that V2. And that's your X or what have you. Now let's look at our pressure, our temperatures over here rather. So I've got 22C. First thing we do is we've got to convert that C into Kelvin. And we do that by adding 273 degrees. You see a pattern there, guys? We've done this for the last 3 days. So anyway, 273 plus 22 equals 295. I believe my math is right. 295 K. Good. Now let's look at this other temperature. It's 30 degrees C. I don't want to put that in there, so I'm going to go over here. All right. And know that I've got to convert that to K. So I'm going to add 273. All right. And you can see what I told you. You'll probably memorize that number before it's over with. So I add that up.
Lulu, come here. Want to go out?
I add that up. All right. And let's see. 3, 0, and 3. So it's 303K. I put that in there like that. Good. Now, first step's done. I've got my my variables out. I see I have one unknown out of the 6. I got that. I can solve the problem. So let's go ahead and write our formula down. So let's go. P1, V1, Boyle's law. Now we're going to do the Gay-Lussac's, Charles's law. Whoop, I said 1, 2 there. That I meant to say 1. There's 1 equals P2 V2 over T2. Cool. Let's start subbing some stuff in. First pressure, 760. Do a little M there, MM times V1, 400 milliliters. All right, and then little sloppy, but let's put our temperature in to 95K. And that's a 5. Let's make sure y'all can see that. It's a 5. 295K. So now I'm going to put my equal sign. My second pressure was 360 millimeters. Whoop. Hang on. Yeah, there we go. Oh, did wrong there. All right, so let's go. Whoop. Let's hit a Control Z. That's not working. So now, problem with new stuff. There we go. Now let's go back up here and draw. Sorry about that, guys. Pen problem. So now we're ready to draw. 360. That's millimeters. All right, and then I got my V2 here because that's my unknown. I put my temperature in. Whoop. Gotta be careful with those buttons. All right, we're gonna go up here and we're gonna hit the eraser and we erase that. Okay, good. Go back to my pen. Stay away from the little buttons. I have to get Angeline to help me there. All right, there's my pen. All right, 303 Kelvin. Now, all I've got to do is do my math, get V2 by itself. That's the one I want to get by myself. So I'm going to do something a little different than I did last time. It's really cross multiplying. It's just a little quicker. If I multiply 360 in the denominator, all right, millimeters, and I multiply in the numerator 303, okay, what can I do? I can cross those out because I'm really multiplying by 1. But if I do it on that side, I've got to do the same thing on this side. So I'm going to use 303, okay, times all that. And I'm going to multiply 360 millimeters in the denominator. Now you can't see the calculator in this video, but that's okay. I'm going to do like I did on that last little video. I'm just going to go 303 times 760 times 400. Then just hit the divide sign. Divided by 360. Divided by 295K. And I come up with 867. 867. V2. 867. That does not look like a 6, but that's what it is. Milliliters for my volume. So there's my answer. V2 equal 867 milliliters. All right. And I can box that in, and that way when I grade it, I'll know what the answer is. 867 milliliters. Let's see what happened. If you look right here, all right, I decreased my pressure, I increased my temperature, all right, and I can't really say in my volume increased. We can think about that. We can talk about it, and theoretically, why would that have occurred? Think about it. Anyway, well, that's my last one for the night, okay? And we'll look at these and see what you think. But have a good evening. I'll see all you guys tomorrow. And it's Friday. Friday, the best day of school. Anyway, talk to you guys later. Have a great night. Come prepared to learn. Come prepared to have a little fun. Got a really cool demo tomorrow. We're going to hear a pop. Talk to you later.